So we are here. We started yesterday with Docker. And when we say Docker, the first thing what we talked about is why do I need Docker? So I talked about that there is a problem. In fact, there is a problem which happens very frequently where the developer develops a code in his environment. And when he deploys it to a prod environment or a different environment, the code does not work as expected. And this creates a confusion, and hence we want a software which will give a uniform environment. And for that uniform environment, I'm looking at a software called Docker. When it comes to Docker, it says you can build, ship, run any software anywhere. So that's the tagline with which Docker sells its product. Now, the Docker tool will help me to create and deploy and run applications with the ease of containers. So today I know what is a container, where I can say that container is a component which will help me to put everything together. So suppose I have a program. So now when I talk about container, I will be putting everything together. And when I say everything, it will contain my code, my library, my dependencies, everything will be put here. And hence, I will not be dependent on the environment. So it will allow my developer to package all the application with all the requirements, the libraries, the dependencies, everything into one single package. And that package will be called as container. Now, with this, I will be able to run the same code in all the environments seamlessly, means without any problem. Now, this solves my problem, but to make this problem or to solve this problem, the first thing which I need to understand is that how is my Docker system going to work, or what is a Docker system? So Docker system or the Docker architecture has three major components: client, host, and registry. So when I say client, it is basically the CLI where I will be running the commands. And here I will be running commands like Docker build, Docker pull, Docker run. And I told you that you can download a Docker cheat sheet to get the commonly used commands. Then the second component which we are talking about here is the Docker host. Docker host, also known as Docker daemon, is the place where the Docker engine or the Docker software will be running. I showed you that Docker can be installed anywhere. It can be a Windows machine, Mac machine, Ubuntu machine, Debian machine, Linux, any variety can work, or Docker can work on any machine. In Docker, I have two components, basically container and images. If you see at a very high level, I will say image and container are the same thing. I gave you an example. I gave you an example of a matchbox, matchstick, and fire. Now, when you talk about matchstick is something which you can store in your matchbox. It's a stagnant thing. It is not going to harm you. So in my Docker world also, I am having images which are just a layered or a union of file systems, which you can keep it as per your requirement in your Docker Hub or any other registry of your choice. When you want to run it, the same image turns out to be a container. And finally, this is the registry or the hub.docker.com in my example as of now, where I'm putting everything together. Then what we did is we told that we will practice Docker. And to practice Docker, I went ahead and I told interactive Kubernetes shell. And when I go with this interactive Kubernetes shell, I'll find that this shell is kind of pre-configured with all the softwares. So I don't have to install any software here. But the good thing here is that it gives me a ready-made environment to work with Docker and Kubernetes. But the problem is it is not active for more than an hour, even less than an hour. And if you go beyond 1 hour, automatically this session will terminate. So for the first thing, what I would like to do is Docker -- version. So I just need to check if Docker is available here or not. And I can see that Docker is available. Now with this, I can start my work. And when I say that I'm going to start my work, the first command which I can generally do is Docker -- help. And here I get the entire list. Whatever commands are available, I get the entire list and I can start my work from here. I told you, in case you're not satisfied with this list, you can go ahead and say that I'm looking for a Docker cheat sheet. and I can get a lot of cheat sheets available over the internet. I can take any one of them and take a printout and start my work. That is how I start my journey. Definitely, it will not be easy for you to remember all the commands. In fact, there is nobody who will remember all the commands. Rather, it should come by practice. The moment you start practicing, these commands you will remember these commands step by step. The second thing which I told you is that to go ahead and create a image or a account on hub.docker.com. So this is a registry where I would like to create a account so that tomorrow I can use it as per my requirement. And here I'm using a free trial. That's why I get a upgrade button here. If you are using the paid version, then it will be the normal one. Now, I went ahead and I went to the repository, and here I can see some 9, 5, 7, 8, 836 images are available. I don't trust all the images. I will only go with Docker official or verified publisher images. Here, you can start with any image, but I prefer starting with Nginx. I told Nginx is a reverse proxy. It stands in front of your web server and allows the genuine traffic to come inside. Okay, and let's go inside. And if I keep going down, I can see these are the supported tags, or you can say these are the versions which are available right now. So if you want, I can start with this version. Okay, so if I click on this version, okay, so if I go with this version, I can see there is something called Docker file. Okay, Docker file. So we will also be creating Docker file, but for this image, this is the Docker file. So let me come here. As of now, I'm not going there. Okay, I will come here and go to tags. Now, if you go here, you will see there are a lot of tags available. Tags are nothing but the versions. So you can see there is a version 1.23 Alpine Perl. So this is one of the version. If you want to use this version, your company says that you want to use this, then click on this, go to your interactive shell and do something like this. Docker, or you have the command, right? So just paste the command. Docker pull, and I'm using Nginx, but 1.23 Alpine Perl. So it will find it locally, not present locally. So it will go connect itself to the internet and it will download this image. Now there is another developer who wants the latest image. Latest. Or he will not mention anything. Okay, he's saying, okay, I'll not mention anything. Now here it says using the default tag as latest, and then it is downloading the image. Now, what happens if the same software I download twice? In fact, 2 different versions. Let's check. So we will go here and say Docker image ls. You say like this, Docker image ls, or if you are lazy like me, you say Docker images. Both of them will work and will give you the same output. So when you say Docker images, I'm not concerned about all of them. I'm concerned about these 2. So let me take these 2. And right click, copy. So you can come here, view. You can see here, I'm using Nginx image. One is the latest version and the other one is the different version. So 1.23 Alpine, and I have the other one as latest. Now, one thing which I can see here is that both have different image ID. It means both of them can coexist. More importantly, this was updated 2 weeks ago and is having a size of 142 MB. And this was updated 3 weeks ago and has a size of 58.5 MB. So 2 images can parallelly exist. Now the question can be asked is how? How can 2 images parallelly exist. So if you remember my 3 BHK example, I told you that in the 3 BHK, I have 3 different individuals who are staying, and they have a mutual agreement that you don't disturb me, you don't disturb me, I will not disturb you, I will not disturb you. So this kind of agreement is there between all the images. And this is the founding stone for my entire Kubernetes and Docker world virtualization. So virtualization or containerization will help me to make sure that the images are not overlapping each other. So if the images are not overlapping each other, then we can make them exist parallelly. Now, they are existing parallelly. Can they run parallelly? So let's check that. Can these 2 images run parallelly? So there is no duplication. No, there will be no duplication. Back to my 3 BHK example. In my 3 BHK, there are 3 people who are staying individually without bothering each other. So there is no duplication at all. So now let's clear all these things. And I want to run the image. So I'll start like this, Docker, and I will say run. Okay. And I will say nginx latest. Okay. So I'm not giving any option. If you remember yesterday when I was running, I was giving -d, -p and all those options. Now I'm not going to give anything. I'm simply going to say Docker run and whatever I want to run. Now, if you see carefully, it has blocked my screen. I cannot do anything here. It is blocked. So whenever you run it like this, okay, we say we are running in attached mode or foreground mode. Okay, so we say it is foreground mode, also known as attached mode. Now, what happens if you run it like this? It will block your screen. Now you cannot do anything here. It is blocked. If you want to come out of this, you say Control C. But the moment you do Control C, it exits or it comes out of the container. And if you say Docker PS -A, PS is for the process. So in your Windows machine also, if something is running and you want to see, you do a Alt Control Delete and it shows you the process, which all processes are running. And then you say end process in case you want to delete it. Similarly, here also Docker PS -A means show me all the processes, whatever is running. So I will see that this container ID is running with the latest image of Nginx, but it is exited. The status is exited, means it is closed. Why? Because I did a Control C. Now, what's the right way of running it? So the right way will be run it in detached mode, Docker run -d. So when you run it in a detached mode, it will not consume your terminal or it will not block your terminal. See, it ran it in the background and gave me my terminal back. And now if I come here and say Docker PS -A, I can see that it is running. And I can see the status is, it was created some 11 seconds back and up and running from last 11 seconds. Now, I used another flag. If you remember yesterday, that flag was --name. And I was giving a name. Let me say sample nginx. Now, if you give a name here, okay, that name will be picked up. If you don't give a name, then a random name will be picked up, like Zen Wilbur, pedant. This is pednatic cannon. So let me just see the names. What are these? So I can see the names here. One is Zen Wilbur and pednatic cannon. So some random names are allocated in case you don't give a name. So we generally prefer, though it is not mandatory, we prefer to give a name of our choice, whatever name you want. So now the container will run, but it will run with my name. So you can see here the name is sample nginx. Okay, so this is the purpose of this flag. Now, I ran one more thing here, which was port forwarding. So generally what happens is if you see here like this, it is running at 80-TCP. So if you see this 80-TCP, 80-TCP, 80-TCP. So where is this port 80 coming from? So generally when people write this Docker image, let me say they have written this, open this. They will do something like this. Expose, and the port is 80. So internally, it will run at port 80. But externally, if you want to run, you have to do something called port forwarding. Now the question can come, what is port forwarding? Shamla, give me 1 second. I'll just explain that. So what is port forwarding? So generally what happens, let me say this is my machine on which I have installed my Docker. Now inside this machine, I have my Docker installed. Now here I have n number of containers. Let me say container 1, container 2, container 3. If you do not expose the port number or you do not do a port forwarding, anything which you run will run within the container. It will never come out. So it will run here only. And anybody who wants to access from the outside world, he will not be able to access it. Okay. So if you want that whatever content you have here in your container, it should be accessible from outside world, you do something called port forwarding. Port forwarding. Port forwarding can be simply taken as that there is a request which is coming and I have to forward it to some other port so that the client is able to see the content. Now let me say Uber. Uber, you know, right, is a mobile app which will help you to book cabs. Now, if Uber is not accessible over internet, how will you book a cab? You cannot go inside the Uber server and book the cab. So you have to do port forwarding. In real-time scenario, you will have to do port forwarding so that the person who wants to book a cab or who wants to access the container from outside world should be able to go inside and do that. Now the question comes, how do I do that? So for that, I have something called port forwarding. Let's do that.
Vikas, sorry for interrupting. Can you help me to understand the previous diagram which you are talking about, the port forwarding?
Mm-hmm. So let me just run that and then I'll show you this port forwarding thing again. So I have already used the name sample nginx. So I'll give a new name and I will say -p. Okay. Externally, you want to run at 9000 port number. It is your call. Okay. Which port number you want? 9000. And internally, it will run at this port number only. Okay. So I want that internally it should, or it is predefined that internally it will run at port 80. I showed you the definition of that Docker image, but externally I can run it anywhere I want. It is my call. Suppose you want to run it at 9000. You run it like this. Suppose you want to run it at 9001. Run it. So now if you come here and see, if you say Docker ps -a, you will see there is something called 0000909001. The simple meaning of this is that any traffic which is routed to port number 80 will be accessed via port number 9001 over the internet. So 000 is over the internet. Okay. So how to test this? Go ahead, come here and run it at 9001. And here you get the welcome page. It says, if you see this page, the Nginx web server is successfully installed and is working. Further, if you want, you can do the configuration. Now, can two applications run on the same port number? Let's give it a try. So already I see that at 9090 and 909001, there is an application running. I would try to run one more application here. 901, the name I will give it as sample nginx 2. Okay. Now here, if you read this, error response from daemon, driver failed programming external connectivity, port 9001 is already allocated, means somebody else is using this port number. So you cannot run two containers with the same port number, which means the container name and the port number should be different. So if you try to run it with the same name and the same port number, it will not work. Let me change the port number and let me change the name. Okay. Realme 3 Pro. So whatever.
Yeah. So I have one question. So yeah, can you hear me?
Yeah, please.
So where do we need to specify this port internally in Docker? So after installing it, do we need to open anywhere?
No. That we will do when we write the image or when you create an image. So as of now, if you see, we are using the images which are already available here.
Okay. But do we need to specify anywhere in the Docker to this 9001 port and all?
Yes.
So where do we need to specify this?
I'll tell you. Hold on. I'll tell you.
Sure.
So if you see this, as of now, I am here, Nginx latest image. When I go to tag, I go to the latest image, or you go to any image, go to latest. And in the latest, there is something called image layers. Okay. So this is nothing but my Docker file. So I will teach you what is Docker file, but image layers. Here you will find this internal port number. This is your internal port number, port 80. This is mentioned here. And that's the reason when I'm running this, I am doing something like this 80. So this is your internal port number. This external port number can be anything. You can give any port number of your choice. Okay. So I am giving, let me say now 8080. This is your choice or the company's choice. So the company wants to run this as 8080. So they say internally it will run at port number 80, but externally it will run at port 8080. Okay.
Okay, we are running that port number and via command, right? So just Docker run is right. It? Oh, thank you.
Yeah. Now I can run this, but one thing which I just now showed you is that the port number should always be unique and the name also should be unique. If it is not, it will not give you the desired result. So now I get the desired result and I can see this is running at 8080. The other one was running at 9001. Now, over a period of time, what will happen is that a lot of containers will come for you. Few are running, few are exited, lot of containers will come. Now, let me say this container is running from last 9 minutes. I don't want to run it anymore. So I can run a command called docker stop and the container ID. So this is my container ID. Copy. Go ahead and paste it. And now if you go with this container ID, earlier it was up and running. Now again, if you go here, you will say it is exited or it is in a stopped state. So any container which is in stopped state, so these are in stopped state, you can delete them. How? Docker rm means docker remove the container ID and this one. So simultaneously I can delete them. So these two are deleted. Now if I come here and say docker ps -a, I will see those two containers are gone. They are deleted. Now, can I do the same thing for these containers? These containers are up and running. These are running. Can I do the same for these? Let me give it a try. Copy the container ID, copy. Come here and say docker rm and paste the container ID. Now, again, I get an error response. It says, you cannot remove a container which is running. And this is the container ID. If you want to stop, if you want to remove it, either stop it first or remove it forcefully. Okay. So there are two ways, either stop the container and then remove it, or remove it forcefully. So let me say, I will say docker rm minus f. So when I say minus f, it is forceful removal. Okay. And copy and come and paste it here. Now I can see that is gone. So earlier it was running 8.6. Now let me see. This is gone. All the one I want to remove. So same thing I can do. Docker rm minus f. This guy. Paste it. Space. Copy. Paste it. Copy. Paste it. Okay. 1, 2, 3, all gone. So now if I come here and say docker ps minus a, I will not see anything. It is deleted. But if I go to docker images, I can see those 2 images which I had created. They have their own image ID. Can I remove them also? Yes. What's the command? So here the command will be docker rmi. So one I will be added. So we are saying docker rmi. So I will say docker rmi and the ID. This guy. Let me just paste it here. Then this guy. And run it. So it is saying deleting and tagging. So finally, these 2 images are deleted. So this is what I learned, that when I run a command like docker run, what does minus b means, what minus name will stand for, what is port forwarding. Now, one very important thing which you will use in your day-to-day work is your data persistence. Now, what is data persistence? Or if I simple term, if I use persistence, what does it mean? Persistence means something which will exist or something which will stay forever. Though it will not be forever, but something which will stay for a long time. So just now I saw that the containers can be easily deleted, created, and dropped, stopped. So when I say a container lifecycle, so if I simply say container lifecycle, so this is a container lifecycle. It will be created. Okay. When you start the container, it will be running. Then you can start or stop the container. It will go in stop state, and you can remove the container and it will be deleted. And if you pause, it will be in paused state. So all these things, if you do, okay, pause and all is not that important, but if you delete the container, it will be deleted forever. Okay. And many a times it is required. Now let me say I'm using Uber. Again, I go back to my example, Uber. So if you see carefully, Uber is a microservice based architecture where Uber is running on Docker containers. So when you do a booking, the trip is active, means the container is running. But the moment you end your trip, the container terminates. So if you want to do a tracking, the tracking is only possible when the trip is active. If the trip ends, then you cannot track your ride because the trip has ended. Technically speaking, when the container is running, you can go inside and do whatever you want to do with the container. But the moment the container is terminated, everything is lost or every item is gone. But many a times, I would like to know the history, like what happened, who did, what was the driver's ID, or what was his payment details. So those details I would like to keep with me. So for that, I have something called Docker volume. So let's come here and just talk about this Docker volume. So if I go to the official documentation of Docker, it says volumes are preferred mechanism for persisting the data generated and used by Docker. If you read this entire history, it will tell you that when you create a Docker container, along with that, some data will be associated, some logs will be generated, some information will be passed. But then when you delete the container, it is gone. Let me show you. So let me say I am having a container. Sorry. So this time I'll run a container. So I've dropped the image. So what will happen is I am running sample nginx 3 at 8080 port number. So first it will pull the image from Docker Hub because I deleted it from my local machine. And then it will come up with a container. So Docker -a. So I can see it is up and running. Okay. Now, because it is up and running, I can go inside the container, or I can see what is happening inside the container. How to do that? Docker exec means Docker execute the command inside the container, and this is the container ID. So you say Docker exec the container ID, okay, and you say bin bash means I want to go inside the container, and here I will use a flag -it. So I stands for interactive, T for terminal mode means when I want to go inside, I need to see an interactive terminal. So the command is Docker exec -it, the container ID, and bin bash. Enter. Now, if you see carefully, earlier you were here. Now you are inside the container. See, this is the container ID. And if you say pwd, present working directory, it will tell you you are at the root folder. Okay. You say ls-l, you will see these many things are there. Docker entry point, etc. These, everything which you see here, it is inside the container. If you exit, means you come out of the container. Now you say pwd, you are at root folder. So they are two different locations. So if I have to show this diagrammatically to you, this is my Docker, and inside the Docker, there is a container. So I'm trying to go inside the container. So when I want to go inside the container, this place, I will say Docker exec -it. So whatever commands I will run, it will get executed here. But the moment I say exit, I come out. And if I come out and run something, then it will run on the Docker machine. Okay. So there is a layer of isolation between all of these. So they are trying to isolate things with each other. Clear this drawing. Now, I want to see that how to go inside the container. So I will just run this command again. Docker exec -it and the container ID. So definitely your container ID will be different. And then bin bash. And you are inside the container, and you can run whatever commands you have. And I have this as the folder structure. This is one way of going inside the container. Okay. But from outside, if I want to see what is the property of the container, or we say metadata of the container, I will come to know that like this. So if I say Docker ps -a, I will see this is the container ID. So I'll use a command like this. Docker inspect, okay, Docker inspect and the container ID, Docker inspect container ID. Now it will give me all the details about this container. See, it is giving me all the details, small, big, all the details. It is telling me about the container. So if you see carefully, this is the ID. This is the date and time when it was created. This is the entry point. This is the Nginx container, which is currently in running state. Okay. There are a few important things. Okay. These things are important, but there are a few important things. First is C, port binding, which I was telling, port forwarding. Internally, it is running at 80, but externally it is running at 80. This is first important thing which you should see. Second important thing which you will see here is that there is something called network setting. So in network setting, you will see that it is saying 80 is the internal port number, 8080 is the external port number, and it has its own IP address. So it is working like a individual machine. It has its own IP address, but only accessible inside. Outside, it will not work. Okay. Then the second important thing is this network. It's a bridge network, and see the IP address. So this is the IP address. Okay. Then another important thing which you will see here is there is something called bind mount, or there is a volume. Okay. So looking for that volume. Volume is what will make my data persistent, or it will. So as of now, if you see volume driver, it is null, means you are not keeping a backup of your data. Volume driver null. So I will go ahead and make sure that I keep a backup of this data. So I'll show you that. Bin is a folder. Bash is a file, right? Bin bash is the landing page. You don't take it like this. Bin bash is the landing page. You can put it like this. Okay. So there are two commands which I would like to run in case I want to know about the container. The first is docker inspect. Okay. And the second command is docker exec. These are the two commands which generally I execute to make sure that my container and the details of the container I am able to get. But there is a small challenge here. If you come here and say docker -a, this container is up and running. But in case the Docker is in stopped state, Docker stop, I am forcefully stopping it. Docker stop and the container ID. Okay, I have stopped the container. Just check. It is in exited state. Now, if I try to go inside the container, see, it is not allowing me to go inside. It says the container is not running. So what should I do? In case I need the data, somebody deleted the data, somebody has stopped the container, somebody has deleted the container itself. So how will we go ahead and work with this? So to work with this, I need something called Docker volume. Okay, please acknowledge me the Docker volume we will discuss now. So we will be talking about Docker volume. How can make two or more containers communicate to each other? So Srinivas, that will come in network section, which I'll take tomorrow. So how could I see my container CPU storage volume bandwidth? That and all you will be able to see in your Docker inspect command. Okay, let me go one by one. You keep your questions, park it aside for time being. I'll take all these details also. Just let me go with the agenda today. And then how to see the details and all, I will let you know. Okay, so we are talking about Docker volumes. Now, if I follow this documentation, this is what I am trying to do. So I have a container and I want to keep a backup of that container, or whatever data is there in that container, I want to keep a backup of that. So there are two ways of doing that. Either you use a Docker volume or you use a Docker bind mount. They basically do the same thing, but there is a big difference between both of them. The difference is if you are using Docker volume, it will always and always store the data in Docker area. So this path is fixed. So if you're using a volume, this path is fixed. You cannot change this. But in case you use a bind mount, you can put it anywhere. So let me say I'm using a cloud environment and I want to put it in some cloud storage. So using bind mount, I can do that. But if I'm using Docker volume, I cannot do that because it will always store the data in Docker area. Now, the question which can be asked is, what is a Docker area? I have never heard about it. Code will be still there in the container. I'm talking about the backup. I'm talking about the data backup. Okay, so let me come here. Now, let me just come here and say Docker volume -- help. So I can see there are commands like create, inspect, ls, prune, rm, and all those things. Let me use them. So I'll start with Docker volume ls. So there are no volumes. So no driver, no volume. I create one. So I'll say Docker volume create, and I'm creating a volume with the name as volume 1. And again, I do Docker volume ls. And I can see on my local machine, volume with vol1 has been created. I need to know more details about this. So I will say Docker volume inspect and vol1. Now here it gives me details like it was created at so-and-so date and time, local, driver is local, and this is the mount point, or this is the place which we are saying Docker area. So anytime when you store your data, it will be stored here only. Var, lib, Docker, volume, vol1 data. So always the data will be stored here. Okay. So this cannot be changed. It is this is in your local machine, or this is in your Ubuntu machine. This machine which I'm running, this interactive Kubernetes shell which I'm running, it is inside that machine. Okay. Now, what I'm trying to do. So I'm trying to do something like this. So let me say this is my container. And I'm saying whatever data you have inside the container, you take a backup here on the local machine. The benefit will be that in case this crashes, everything is gone. From here, everything is gone. But still, I will have a backup with me. And later, when I start, I don't start from 0, but I start with this data. So the backup is taken at a different location. It is not within the container. It is outside the container. So the good thing what will happen here is any data which you put inside the container. So this is my container. Any data which is here will be automatically backed here. So if you make some changes here, it will reflect here. Make some changes here, it will reflect here. So at any point of data, at any point of time, I will have data backup. More importantly, I have multiple containers running. Multiple containers can access this volume. So the volume can be a shared one. So the moment I share the volume, so let me say I have 2 accounts, okay, 2 accounts, and I want to share the data between both of them. So I can use a common volume and I can share the data between both of them. So let's see how we can implement that. Not exactly slave, but kind of, not exactly. Okay. So let me clear all these things and let's go ahead. So this time when I create a container, first let me check if some container is running or not. Docker ps -a. And let me delete this Docker. So it is in stopped state. So I don't have to give -f. You can simply delete this. So now if I come here and say Docker ps -a, I can see nothing is running. Now, this time I will use the volume thing. Now, if you're not aware of the syntax, you can come here. What happened? Wait a second. You can come here only. Here it will tell you how to use it. Don't go with -mount, go with this guy, -v. Go with this content, bring it here. Let's try to understand what they're trying to do. So they're saying Docker run -d. So they want to run it in detach mode. -name, they're giving a name as dev test. You give your choice, a name of your choice. Then it says there is a flag called -v. -v, and I will give my volume name. So my volume name is vol1. Okay. Here I will say whatever data you see inside the container in app folder, you back it up here. Other way around, whatever data you see in volume 1, back it up here. So this is inside the container. This is outside the container. Okay. And what container are you planning to run? I'm planning to run Nginx latest image. Let's try to run it. Let's maximize it. Let's run it. So I have not changed anything here. I'm just mapping this thing. And when I say -v, I'm using a volume. And I'm simply saying inside the container, there is a folder called \app. Inside that app, whatever data you see, map it to my volume1. So both of them will be mapped to each other. Or you can say constantly backup will be taken for it. Let's run it. Now let's go ahead and say docker ps-a. I can see the container is running. If I want, I can go inside the container, copy this content. I will say docker. I will say docker exec because I want to go inside. Docker exec -it, and then the container ID and bin bash. Okay, so I'm saying docker exec -it, the container ID, and bin bash. Now, if I do ls-l, I will see there is a folder called app. And as per my command, it says any data which you see in app should be backed up here. Okay, so let me go ahead. Volume will be stored outside. Yes, it will be outside. It is not inside the container. It is outside the container. So any data which you store here in the app folder will be backed up here, which is outside the container. So let's go and check cd app. So I'm going inside this app folder. You can see I'm inside this app folder. Here, as of now, if I do ls-l, I don't see anything. What I will do is I will try to create a file here. So touch is a command, and I will say touch sample.txt. I cannot use nano and all because I have to install that tool. So I'm simply saying touch sample.txt. And now if I say ls-l, I can see a file called sample.txt, and it is 0 bytes, means there is no data here, but it has been created on September 6th. This is the date and time I can see. If I want to push some data, I can do it like this. Echo is generally a print command, but I'm trying to use echo and push some data there. Pushing data from the container. CONTAI from the container. And where do you want to push this data? I want to push the data to sample.txt. Okay. Now, if I just want to view the data, I can say cat sample.txt. So if this time I come here and do ls-l, I will see 32 KB of data is there. September 6th, 1421, the data has been pushed, and the name of the file is sample.txt. Now, as per the command which I ran, okay, now let me exit from here. Exit. Now I'm coming out of the container. Now, as per the command which I have run, I told that whatever data I put here should be copied here. And as of now, I can see in my app folder, I have this data, sample.txt. It should be present here. Now, where is this volume1? So I will come here and say docker inspect volume1. So this is the location. This is the place where it is. And this location is in my local machine. It is outside the container in my local machine. So I'll say cd and I'll go to this path. Copy, paste it. So this is the location. So if I do ls-l, I should see sample.txt, and it is exactly same to this guy. 32 bytes, September 6, 421, sample.txt. Exactly the same. Now, if I add something, or just let me see the content is same or not. Pushing the data. Now let me add some data. Now outside container, right? I can use my nano. So nano sample.txt. Here I am saying adding new line outside the container. Okay. Now, if I simply do a cat of my sample.txt, I can see two lines are there. ls minus l, I can see it is now 70 kilobytes, 70 KB data. Let's clear all these things. Now, we'll go inside the container and check if the data is backed up or not. How do we go inside the container? This is the command. Here we will go inside app folder, and here I will say ls minus l, and I can see this sample.txt. The content is 70 KB. And if I just view the content, yes, I can see my additional content. So one thing which I'm sure is that the content is now being backed up. Whatever data I put inside the container, that is being replicated outside the container in my volume 1. Now, exit from here. Why I was doing this? I told that the containers are persistent in the sense the containers can get deleted. Okay. So the containers can get deleted. Local machine is nothing. Yes, local machine is your VM. You can say VM. So now when the container is running, everything is working fine. But assume that this container, somebody deleted it, or due to some reason, the container got deleted. Docker rm minus f and this container ID. Just remember, it is BACE, ends with BACE. So the container got deleted. If I come here and say docker ps minus a, I can see no container is there. But container is gone. Is the data also gone? The answer is no. The data is still with me in my volume. So next time when I'm creating a new container, I will come up with something like this. I will again say docker run. I will give the same name, or I can give a different name. Name is not important. This is important. So I'm saying I have the backup in volume 1. Whatever backup I have, you put it here in the app folder and run the latest version. Docker ps minus a. I can see this is my container ID. A new container got created. And docker exec minus it. Paste the content. Bin bash. I am inside. Go inside app, ls minus l, and you see the file has been backed up, but the file is already present. Now exit from here. Can this volume be used by some other container? Let's try. So I'm running one more container. I will say prod test. Instead of dev test, I'll say prod test. And I'm using the same volume and the same content, but a different container. Docker ps minus a. So I can see that there are two containers, 1, 2. Both of them are using the same volume. How can you confirm that? Wait, I will confirm you that. So I will go here and say docker inspect vol 1. And I can see. Okay, I will not go there. I will go here. It's not showing here. Docker ps minus a. So I can go here and say docker inspect the container ID, copy, paste. So here I will be able to see that volume 1. See here. So this guy is using volume 1. Okay. What container is this? This is the first container. So I told B7927. So this one is using volume 1. Similarly, if I go with this guy, docker inspect.
Papa, where your clothes? Papa, where your clothes?
Here also,
Where your clothes?
here also.
Papa, where your clothes? Not like this, Papa.
Wait, you go, I'll come. Here also, if you see, you are using the volume as volume 1. Okay. Now, at any point of time, if I change the data, so let me come here and say docker ps minus a. I am inside this. So inside this, I will say docker exec minus it paste bin bash. Okay, cd app ls minus l. So this is the data. At any point, if you change, here also it will change, here also it will change, and it will also change on your volume. Okay, so these are the 3 places where it is in sync. Or we can say the data is persistent or the data is being saved. Okay, so today I will close it here. I will open it for questions. If you have questions, you can please go ahead, and you can also write the questions in the chat window. You can go ahead and tell me if you have any questions, or if you raise your hand, that's also going to work.
Because that app folder we are giving, right? Normally we can give the complete Docker
Yes,
thing, like
you can. Yes, you can give any folder you want. In case you don't want to back up only one folder, you want to back up everything. Let me say I want a backup of everything. So you can put it like this. It means the entire content will be backed up.
okay. And one more thing, while after deleting the container, the volume is not deleting.
No, the volume will not be deleted.
But when we attach the volume to container, it is auto-replicating. Both are auto-replicating. When we do the changes in the data in the container, it will replicate to volume. And when we do in the volume, it will replicate to container, right?
Yes, yes. How can I change the volume path? So this volume path cannot be changed. If you remember, I told you here that ideally, this volume thing cannot be changed. You can see here. This container volume is always mapped to this Docker area. Yes, if you want, you can change it using bind mount, which I'll show you tomorrow.
Vikas Monish here.
Yeah.
In the Docker running time, can I attach another volume?
See, ideally, we should not do it. Okay. Generally, if I have to do some changes, okay, I will first stop the container, do whatever changes I have to, and then bring back the container. So ideally, we do a Docker stop, make changes, and then start the container again. But there are tricks, or there are ways in which by which I can put it in the running container, but that is not recommended because that will give you unexpected results.
No,
Wait,
I have a quick question, please.
Currently, it's mounted as a volume 1 is in the app/app, right?
Yes.
I have volume 2.
Okay.
So if I want to mount that volume 2/app2, so
2 volumes you want to mount,
is it
right?
possible to? Is it
Yes,
possible to?
it is possible.
Running content.
Yes, it is possible. So if you want to attach it to 2 volumes, it is possible.
Okay, thank you.
Where do we restrict and unrestrict the networks in the containers? So as we have, as you shown, right? So if you go to the inside of the container, so we have seen that networks, right? So we have opened that entire wire, and
tomorrow is what we will talk about the network. So we will come to Docker network tomorrow. I will be talking about these things, restriction of the network, and all these things I'll be talking tomorrow.
okay.
I noticed that when you write the command to attach the volume, you didn't include the port mapping or forwarding.
No, you can. That is optional. So I just skipped that. But in case you want to do it, you can do it. So this is your question. And if you say that I want to do a port forwarding,
yes,
Yes, you can do this also. Just change
Okay,
the name.
perfect. Very good. Appreciate it.
Yeah. Now, so all these things which you see here, all these things are optional. So it will totally depend on you whether you want to have it or you don't want to have it. And if you don't want, you can simply skip and the default values will be taken.
Because like volume is main purpose is to backup containers. That's
Yeah.
it.
That's it. To make the data persistent means tomorrow if my container dies, terminates, I should have my data.
Okay, it's only container backup.
It's a container data backup. You can say container data backup.
Okay.
Because regarding this port forwarding for the external resources login, what could be the port range we'll be using? It can be
Port
0 to
range
65.
can be 0 from 0 to 65537. I will just let you know the port range.
Okay.
Port TCP port range, you can see TCP port range 0 to 65536. This is the range. You can use any range within this.
Sure.
Generally, companies they have their own range. They will work within that range. So when I come to networking, I'll tell you that companies buy their own IP addresses, and then they share the IP address and the port number with that.
So I have one more question, because like you mentioned 2 ports, right? Internal port and external port. When we see internal port in Docker file, so can we change according to our environment within?
That is when you are using or when you're creating your own image. As of now, the images which I'm using is pre-configured. It is already there. If I have to change it, then I will write my own custom Docker image where I will go ahead and change all these things. So
we can modify even like existing one as well, right?
No, existing one you cannot modify. Okay. Those are from official company. The company itself is releasing it. So you can't modify them. You can create your own.
Own Docker file and then, okay.
Yes.
Oh, got it. Thank you.
Anji, you wait for some time for the answer to this question. I'll let you know, not right now. This is not the right time for this answer.
Because Docker area volume and Docker bind mount or something you mentioned, right? What is the difference?
So bind mount, you can see, suppose you have a machine running on your local, okay? And your manager is saying that I want the data to be backed up on a central server. Okay. So you cannot use volume because volume will map it to your Docker region only. If you want to map it to some other location, then you use bind mount, which I will teach you tomorrow how to do this.
Oh, okay. I thought it's a volume is completed today.
No. Bind mount will come tomorrow.
Okay, thank you.
Because Docker containers will be running on top of the VMs, right?
It is not important. Containers can run anywhere. It can run on your VM. It can run on your cloud machine and your Windows machine, on Ubuntu machine, on the Mac machine. It can run anywhere.
Okay, let's take EC2 instance. So in EC2 instance, a container is running. So if you back up the volume, it is outside the container, means it is in the local EC2 instance, right?
It's a local EC2 instance, correct.
Okay.
Now from there, if you want to take it to a S3 bucket, then you have to use bind mount and all those things.
Okay.
Wait, Angie, when I'll start integrating, then you will come to know. Give me some time for that. Let me just clear these concepts and then come back. I will show you how to integrate it in a CI/CD pipeline. Then it will become much more clearer to you. Okay, fine, guys. So we meet tomorrow. We'll share the recordings and please do practice and then we meet tomorrow. See you then.